Okay, so today we're going to be going over section 1.2. And in 1.2, we're going to be talking about equations. We're going to be talking about what is an equation. We're going to be talking about, let's see, properties of equality, solving one-step equations. We're going to be talking about solving multi-step equations. We're going to be talking about solving for a particular variable. So this is going to be a pretty packed lesson, so I apologize in advance for it being a little bit longer than most. But once again, most of this for Algebra 2 should be review. So you want to skip through to the parts that you might need the most help on, or if you're like, I'm good, that's fine. But the biggest thing is that you're expected to know how to do everything in this video, whether you watch it or not. So, all right, well, let's get started. So what is an equation? Well, an equation is just an algebraic sentence, basically with an equal sign. Obviously, the biggest thing about equation is you got to think about the equals sign. There's an equality there. There's something is equal to something else. For example, if I say that x plus 5, which is an algebraic expression, is equal to this other algebraic expression, I don't know, 2x minus 7 or something like that. Okay, I say that x plus 5 is equal to 2x minus 7. This is an equation because there is an equal sign right here. Okay, now we can solve this equation for x, and we will talk about how to do that in a minute. But the main thing is the equation, this sentence, this algebraic sentence, has an equal sign. Once again, that's why it is an equation. So if I said, okay, I have x plus 5, would that be an equation? No, because there is no equal sign in this sentence. It is an algebraic expression, but not an equation. Now, with equations, we can go about solving them because they have certain properties. Those properties of equation, we'll start with the first one, is that they have the reflexive property. Basically, it says the reflexive property states that any number a is equal to itself. All right, any expression is equal to itself. So if I have b plus 6 or something like that, that is equal to b plus 6. Every number, 7, for example, is equal to itself. The second property that a property of equality that I want to talk about is that we have equations are symmetric. Symmetric means if A equals B, then B also equals A. So I could switch it either side. So for example, if I say A plus 7 equals 12, I could instead flip this around and say 12 equals A plus 7. It doesn't matter. We know that it's symmetric. You know, think about symmetry. It looks the same on both sides, right? So I can flip these and it doesn't really matter. The next property of equality that I want to talk about is the transitive property. And the transitive property basically says this: if I have sum A is equal to B, and then I have B is equal to C, then A is equal to C. And I want you to I'm going to kind of draw this arrow to kind of show you all what's going on. So I'm saying my A is equal to some number B, that B is equal to some number C, so therefore my A is going to be equal to C. Now, an example of this, x plus 6 equals 12. And then we said 12 equals y minus 4. Well, then we can say that x plus 6 equals y minus 4. That's the transitive property, because this thing that is connecting, this 12 is connecting the two, right? And that's the transitive property. The last property that we're going to talk about is substitution. So with substitution, basically you're saying that if A equals B, you can replace A with B. So an example of this would be, okay, let's say I said A equals 6, and I said A plus B or something like that equals 7. Well, I can take this A and replace it with 6. It's kind of like the transitive property, but it's substitution because I'm not replacing the entire equation here. So I'm taking 6 and I'm going to put that into where A was. And that's what we call substitution. I'm substituting A for 6. All right, solving one-step equations. Solving one-step equations. All right, these are the easy equations where we're going to use the properties of equality to find some x. So for example, let's say I have x plus 6 equals 12. Well, if you just think about it, you can say, okay, well, if I have x plus 6 is equal to 12, then the number x must be 6. Why? Because 6 plus 6 equals 12. But here's what I want you to think about. I want you to think about it like this. We want to isolate the variable. And isolate means to get by itself. We want to get it alone. For example, solitary confinement, you are alone, right? We want to get this x all by itself. So the way we do that is, I'm just going to rewrite the problem real quick. X plus 6 equals 12. To get x by itself, we need to do something that's the opposite of this operator plus. Okay. Instead of addition, what's the opposite of addition? Subtraction. So we're going to subtract 6 from both sides. We're subtracting 6 from both sides. Why? Because we're trying to get rid of it. We want x by itself. So we have positive 6 minus 6 is just 0. So that goes away. You're just left with x on the left. And then you have 12 minus 6 is just 6. That's it. Okay. What if you had x minus 6 equals 12? What do you do there? Well, let's think about it. If you have negative 6 here, what's the opposite of negative 6? Or what's the opposite of subtraction? Well, addition. So we're going to add 6 to both sides. So now we have x equals 18. Now, what if you have something weird like a decimal? What if you have like y minus 3.5 equals 7? Well, there's no change. What's the opposite of subtraction? Well, addition. So you have plus 3.5 plus 3.5. Once again, you're getting y by itself, and you have y equals 10.5 in that case. Okay, so we talked about subtraction and addition. What about multiplication and division? Well, let's say that you have 3 times x equals 6. And the way that we would really write that is 3x equals 6. Well, what is the, right here we're multiplying. Well, what's the opposite of multiplication? Division. So you would divide both sides by 3. So that now gives you x equals 6 divided by 3, which is 2. What if you have 4y equals 24 or something like that? Or actually, let's make it 4y equals 2.4. Well, once again, it doesn't really matter that we're dealing with the decimal here. We do the same thing. We divide both sides by 4. You will find then that y would be equal to 0.6. All right, now what if you have to divide? So what if you have y divided by 4 equals 7? You're trying to find some number y that if you divide it by 4, you will get 7. Well, the number is 28, right? 28 divided by 4 is 7. That's the number that we're looking for. But let's say you didn't know that. Well, once again, think about the opposites. I have y is being divided by 4, so what must I do? Multiply by 4. I'm going to multiply by 4 to both sides, and I end up with these two cancel out, and I end up with just y equals 28. Well, what if you had 3/4 x equals 9? Okay, what do you do there? 3/4 x equals 9. What should I do? Well, think about it. I'm going to multiply by 4/3. Why would I multiply by 4/3? Think about it. You want to cancel the 3's and you want to cancel the 4's, right? So we multiply by flipping this fraction. We call that the reciprocal. So you take the reciprocal of 3/4, which is 4/3, and you're going to do that to both sides. You're going to multiply by 4/3 here. Now, then we have x equals, you can think about this 9 or any number for that matter is like 9 divided by 1. And remember, multiplying fractions, you're just going straight across. So 9 times 4 is 36. And 1 times 3 is just 3. So the answer is 12. 36 divided by 3, which is 12. Now, that's one way to think about it. You could also divide by 3 first. You could have said 9 divided by 3 is 3, times 4 is 12. Both answers, both ways get you to the same spot. All right, solving multi-step equations require you to do more than one step. The easiest is two-step equations. For example, if you have something like 5x minus 3 equals 12. All right, 5x minus 3 equals 12. Well, what you usually want to do is kind of think about it in terms of PEMDAS backwards, okay? So the easiest thing to do here is to get rid of the subtraction part first. Because remember, to solve an equation, we're trying to get the variable by itself. We're trying to isolate the variable. So the easiest thing to do is actually going to get rid of this 3 first and then deal with this 5 times x. So the way we get rid of the 3 is we're going to add 3 to both sides. Then we have 5x equals 12 plus 3, which is 15. Then we have, now we have a one-step equation. 5x equals 15. We can now divide it by 5. And we get x equals 3. So pretty simple two-step equations. So we got 3 times x, the quantity, x plus 6, minus 4 times the quantity, x minus 2 equals 23. All right, how do we solve this? Well, in this case, we're actually going to do PEMDAS in the way that it's supposed to go. And once again, you're just going to, just by practicing, you're going to do some things. The first thing I'm going to use is the distributive property. Okay, which basically, if you have some number in front of a quantity with parentheses, you're going to multiply out this number by both numbers inside. Okay, so 3 times x gives you 3x. 3 times 6 gives you 18. Now, here's the trick. We're going to do it again here, but think about this number not as 4, but as -4. Okay, when you see algebraic expressions, it's oftentimes easier to think about them in terms of -4 as opposed to subtracting 4. Okay, so in this case, we have negative 4 times x, which gives you negative 4x. Then you have negative 4 times negative 2, which gives you positive 8, which equals 23. Okay, so now what we're going to do is combine like terms. We've got like terms here and here, and we've got like terms here and here. So we do 3x minus 4x gives you negative x. 18 plus 8 gives you positive 26. So positive 26 equals 23. And then from there, we can now subtract 26 from both sides. And we are left with negative x equals negative 3. Or notice, since we have both negatives on both sides, we could multiply by negative 1. And that would give you just x equals 3, which is your answer. Okay, so in the first section, we talked about formulas. And in geometry, which most of you took last year, you had a whole bunch of formulas that you had to memorize. And one of them was the formula for a trapezoid, which is area equals 1/2 base 1 plus base 2. Okay, 1/2 base 1 plus base 2. And that would be the area of this trapezoid, where this is base 1, base 2, and then times the height. And then your height would be right here. Okay. And if you had, you took geometry last year, you remember the reason this is because you got to think about it as in terms of actually two triangles and all that good stuff. But this is the formula or equation for area. Now, let's say I gave you a word problem. Okay. And I said, let's say that you've got some kind of, you have a field. I don't know why you would have a trapezoidal field, but you have a trapezoidal field. And you're trying to put grass down on this field. And you want to figure out how much grass you need to purchase. Okay. So to do that, to find out how many square feet of grass, or let's say you know how many square feet. Let's say you have 72 square feet of grass that you need to put down. So we'll say the area is 72. And let's suppose that we know that the length of this base right here is 12. Okay, we know the base length is 12. Say the base length up here is 6. So base 2 is 6. So we know base 1 is 12, base 2 is 6. I want you to find how tall, we'll find the height. Okay, so the area is 72, say feet squared or something like that. Base 1 is 12, base 2 is 6. We want to find the height. Well, what we're going to do is we're going to substitute or plug all of these into this expression and then go from there. So the way that we do that is we're going to say, okay, 72 equals 1/2 12 plus 6 times h. Remember, h is the one thing we don't know what it is yet. So we have 72 equals 1/2 times 18 h. 1/2 times 18 is 9. So you're going to have 72 equals 9h. And then divide both sides by 9. You'll end up with h equals 8. And that's it. I hope you all found this video helpful and somewhat interesting. It should be pretty much a review for everybody. Stay tuned, and I'll look forward to seeing you in the next video.